First of all, thank you for the invitation, and I also thank the collaborators from the region of Western Greece. My name is Stavrakakis. I come from MES Energy SA, and we are the external experts of region of Western Greece for the project Impulse Plus. I'm also very happy to be here because I see very familiar faces as being the former coordinator of the Impulse project when collaborating with CRES in the recent past. So hopefully this will be the flagship for new collaborations again between all of us. As an introduction, I would say that what is the motivation and the triggering of the region of Western Greece to participate in this project in the first place, but as well as to be an active partner and also attract its municipalities to get involved. The energy efficiency of the public building stock remains a key priority in the regional sustainability policies and strategies. Another motivation is that the region seeks, through its participation in such innovative projects, for novel insights to contribute in designing innovative energy efficiency programs, especially in the framework of regional operational programs. And it is true that it is now the time to update the regional operational programs so as to handle many buildings, so as to handle a bundle of buildings. And ever since the recent energy efficiency directive, this is inevitable. Another triggering point is, of course, the new law 4843 of 2021, which for the first time make it obligatory for regions and municipalities to conduct, implement, and monitor public building stock energy renovation plans. And these renovation plans should be submitted in the Ministry of Energy and Environment, I think every two years, also including monitoring results. So this is a major difference in the recent in comparison to the recent years, because these plans were not obligatory. Now they are, and in fact, regions and municipalities must submit these ERB plans by the end of this year to the ministries. So what are the challenges raised? Of course, one challenge is the data collection and processing for many buildings in order to conduct a reliable plan. Another challenge is to obtain reliable parametric energy analysis for many buildings in order to understand and prioritize the package of measures that we need to plan and implement projects. And of course, how to prioritize the feasible projects based on energy, environmental, and economic performance towards the formulation of a reliable gradual renovation plan. Through exercising the Impulse Plus tools, we identified some key points that must be mentioned and demonstrate how the Impulse tools actually tackle these challenges. So first of all, we identified the building stock in collaboration with the region. In a second step, we completed the most important data influencing building energy performance in the first tool, the public building typologies tool that provides the library of public building and typologies, and proceeding furthermore in order to classify the identified building stock into representative typologies based on common characteristics among them. In a second step, we should decide which are the ambassador buildings, the most representative ones, in order to complete the requested ambassador sheets in the tool public building typologies. It is inevitable that we must perform an external parametric energy analysis for each ambassador building, but keep a great notice on that. You have, for example, the previous speakers, you have a tremendous sample of buildings. What Impulse gives you is that you don't have to make extensive energy analysis and simulations for all your buildings. in the assumption that you achieve a very, very good classification, only a small amount energy analysis of just the ambassador buildings allows you to get indicators and KPIs for all the buildings. This is a major contribution of the Impulse project and must be understood by the potential users, which are regions and municipalities in the Mediterranean. So I will repeat myself again and again in my presentation here on that issue. Afterwards, the completion of KPIs for the base case and various retrofit levels for ambassador buildings, and KPIs extrapolation in the tool KPIs processing. I forgot to mention that we, in the external parametric analysis, we ensured the various retrofit levels on an aggregative manner. It is important also to be mentioned that the Impulse tools work very well when one ensures the aggregative nature between the retrofit levels, meaning that the medium retrofit contains the minor retrofit measures, the major retrofit contains the previous ones, and the final one, the deep retrofit, contains all the three previous retrofit levels. And finally, we exercised the plugin, the KPIs processing plugin and the financial schemes towards a gradual renovation and financing plan. So let's see what happened. As per the directions of the region, we identified only 11 buildings, but this is because these 11 buildings are owned or managed by the region. So the region is the total responsible of the sole responsible of these buildings. The stock mainly includes office buildings, the headquarters of regional units, and some divisions of public hygiene and transportation and communication divisions, as well as some public vehicle technical inspection centers, the so-called KTEO in Greece. That is the Greek abbreviation. And we decided that the best classification criteria is the building use, of course, the construction period, and you can see also the ranges adapted in relation to the regulatory framework regarding the energy performance of buildings. So by now, everybody knows that the year 1979 is the milestone year, because for the first time in Greece, we adopted the regulatory framework about thermal insulation and thermal protection. Then the 2010 is the next milestone year, because for the first time the Greek EPPD was introduced. The floor area was another important criteria, and of course the heating and cooling systems, with a main discretization criteria regarding the energy carrier, whether it is fossil fuel or electricity. So, for example, oil boiler, heat pump for the heating system, and the cooling system, a heat pump. So you can see at the bottom of the slide the table of all the selected buildings, the floor area, and you can see with red marked the main criteria used for classification. And you can see that the buildings are classified into three major typologies. And in the same tool, we completed all the details of each ambassador building just to have an energy, let's say, an energy identity of each typology as reflected by the ambassador building selected. So just a few comments. You can see that for the first typology, we have the Vehicle Technical Inspection Center and Regional Unit of Ilia. It is, of course, its use may be considered as industrial, but if it's not the use introduced in administrative documentation, then I'm afraid that it won't be included for funding, because the forthcoming programs, such as the regional operational programs, such as the Electra, that we are so eager to for at last have the invitation released, They include mainly office uses, school uses, hospital uses, etc. So we decided to concentrate to the office building units when talking about the vehicle technical inspection centers. It was much more wise to focus the study on the office units. So even these buildings were handled as office units, and it is true that normally the half floor area of these facilities are totally office use, and the other half contains all these mechanical instruments that a common vehicle technical inspection center uses, and actually there is not much space for someone to do something there. So let's consider them as well, these building units as office units. The period of construction is 1980 to 2010. The floor area ranges between 500 and 2.500. The heating system is oil boiler. The cooling system is mainly heat pump, and it reflects 8 buildings. You can see the details regarding the building envelope, the vertical walls, the roof, the windows. It is important to mention that this building is being constructed after the milestone year 1979, contains an intermediate thermal insulation which brings a U value of 0.7 watt per square meters per Kelvin, and some other characteristics about the roof and the windows. You can see also the recording of the heating system. We have a central heating system, oil boiler of 95 kilowatts and 88% nominal efficiency. The cooling system, we have a central heat pump of an energy efficiency ratio of 2.6 and other details. I won't get you tired with that. The second typology is reflected by the Division of Public Hygiene Building Regional Unit of Achaia, located in the city of Patras. It reflects 2 buildings of the initial sample of buildings, and you can see also the recordings regarding the main characteristics used as input conditions in the energy parametric analysis afterwards. And finally, we have another industrial, let's say, use building, the Vehicle Technical Inspection Center in Regional Unit of Achaia, which actually is a singular typology because it includes only 1 building. And you can see also a photograph and the location of the building, also the boundary conditions regarding the thermal the U value, and the recordings about the building systems. Here we have again a central system with oil boiler, a cooling system with AC air conditioned split units, manual natural ventilation only through openings, and linear fluorescent tubes of 18 watts in recessed ceiling luminaires. Now, it is important, I forgot to say that the second typology just recently subjected to renovation, which included the replacement of lighting systems. So you can see that we already have a LED lighting system here. We have also new double glazed with aluminum frame air gap. The U value is 3 watt per square meter per Kelvin. So this was also a subject of renovation. And I don't know if it was something else, and perhaps some new terminal units for cooling and heating. So this is interesting because one considers what to do. So of course there is room for more energy saving potential, and I will demonstrate later. Regarding the external energy analysis, we adapted a zonal model of quasi-steady monthly time step computation based on the EU standard DNI ISO 13790. The input conditions were produced by processing the collected data based on the Greek EPPD technical directive, Energy Performance of Buildings Directive. And the computed situations included the base case, the existing situation of the building, the minor, the medium, the major, and the deep retrofit, ensuring always the aggregative principle, which means that the medium and deep the medium and major retrofits includes the minor, the small scale retrofits. And as moving towards to the deep renovation, it also includes all the previous ones. And just to demonstrate in this scheme, in the small scale, we ensured we studied the simple compensation system with or without thermostatic valves of the terminal units of the heating system, replacement of lighting fixtures with LED. And I think in the second typology, we also included the replacement of window and door frames. In the medium and major retrofits, we ensured the thermal protection of the building, and in some cases, the enhancement of the already but inadequate thermal insulation recorded in the buildings, the replacement of window and door frames, and in the deep renovation, mainly we focused on the installation of renewable energy systems and mainly net metering with photovoltaic systems. Now, you can see in this table the exact measures adapted for each retrofit level. So, for example, in the first typology, in the minor retrofit, we have the boiler compensation system and the luminaires replacement by LED. In the medium retrofit, includes the minor retrofit measures plus the windows replacement by PVC openings and low emittance glazing and roof insulation. In the major retrofit package, we enhanced the medium retrofit by testing vertical walls insulation. And in the deep retrofit, we added the photovoltaic of 10 kilowatts peak grid connected, ensuring the net metering mechanisms. Here are some results. You can see the travel from the base case to the deep retrofit, and you can see how the annual final consumption per energy carrier changes, and in fact reduced as regards the conventional energy carriers such as the electricity and the oil. And you can see that finally the energy share coming from renewable energies covers the 39% mainly regarding electricity. So this number 23.8 actually compensates the electricity 26.7 that you see here. So we are talking about a dramatic quenching of the electricity consumption. You can see also a dramatic reduction of CO2 emissions when talking about this single ambassador building. And we elaborated a bit regarding the economic performance, because this is indeed something important, and any investor always focus on. And you can see that we have a dramatic reduction of the annual energy cost by 9 times, as you can see, as moving from the base case to the deep retrofit. And interestingly, the payback period is when talking about advanced retrofitting levels is much more attractive in the deep retrofit case, and this is quite good because this is a scenario more expensive than the previous ones, but because of having an office building, the payback period is reduced as a result of mainly of the photovoltaic system. And this is a great result, especially in comparison with school buildings, where, as far as I remember correct, in the previous Impulse project, in school buildings, we have trouble in demonstrating good economic performance, because school buildings, at least in Greece, are closed for at least 2 months or 3 months throughout the year. So this deteriorated the economic performance of the investment. And you can see here some graphs of the cash flows, demonstrating also the attenuation periods. Similar results for the second ambassador building and for the third ambassador building. I won't get to more details on that. We proceeded further now, having all the database produced only for 3 buildings. We inserted now all the KPIs for these only 3 buildings to the Impulse tool. We inserted for the base case scenario, the minor retrofit, the medium retrofit, the major retrofit, and the deep retrofit. And the tool provides itself the automatic, first of all, the automatic prioritization. And I will insist more on the second table, where what it gives you is which building is better according to total annual energy saved. You can see that in the minor retrofit, it is better to start with the first typology, continue with the second typology, and finally with the third typology. And you can take a similar prioritization of buildings and projects for the several retrofitting levels. Now, again, the tool automatically extrapolates the impacts for all the buildings. So here is a great result. We had KPIs only for 3 buildings, and now these are extrapolated to all the 11 buildings of the initial sample. And just indicatively, you can see that in the minor retrofit, we can achieve a reduction of total annual primary energy of about 27%. This becomes 36% in the medium retrofit, but the payback period increases in a prohibitive, let's say, value, but it is healed when talking about to major retrofit and especially deep retrofit when elaborating with when enhancing the scenario with photovoltaic panels. And you can see the extrapolated impacts for all buildings. We perform some graphs here, and you can see the share regarding the energy carrier in the existing situation. And as we are moving towards the deep retrofit scenario, you can see a tremendous contribution from the solar energy. And regarding absolute values, if the plan goes well, then and according to these theoretical predictions, then this means that the region could achieve more than 1.5 megawatt hours energy savings regarding primary energy consumption, and also avoid more than 500 tons CO2 emissions per year. Regarding the economic performance, you can see that regarding all buildings, we have good internal rate of return, and especially for the deep retrofit, we have an 8%, which is a bit higher than the inflation inflation rates that we have right now in Greece. The situation is not so good, so it is encouraging that we have good results even under this economic crisis that we are experiencing again, not only in Greece but in the whole Europe and in Mediterranean, of course. So we used the KPIs processor plugin. We provided when balancing the preferences in indicators, we provided more interest, more weight to the energy savings and the CO2 emissions avoidance, and of course to the the reduction of the energy related operational costs, and less interest was paid regarding the investment cost and the simple payback period, because indeed we cannot deny that in Greece we will have a renovation, a funding for the renovation wave, and it's coming through the Electra program. There is an increased interest, so we could assume that there will be enough money, but not grants. There will be enough money by means of loans, investment loans, because only with grants we have no hope to achieve the energy renovation of the whole public building stock in Greece. That was for sure recognized by the ministry when designing the Electra program. It was not really necessary for us to provide more penalties regarding a specific typology or a specific type of retrofit. We provided a 10% retrofitting area per year because there is much room for the region to implement that project. We adapted as a first approach the targets coming from the second tool as upper limits, and we ensured all the combinations available to be involved in shuffling all the public buildings and retrofit levels in order to have the results. So having the weights more concentrated in the energy and the CO2 emissions avoidance, you can see that the deep retrofit gets the greatest score in relation to the other retrofitting levels. That means that the plan highlights only deep retrofits, and this is acceptable for the region because the amounts of money looks feasible and can be eligible in European program, in national program, or even in investment loans. So you can see here the specific buildings that are recommended from the plan, and this is again something very, very useful for regions and municipalities, because you know a politician won't stay to understand these graphs. He won't, or she. They won't stay to, but they will understand the veil, the provided veil of projects, what project to do in each year in the forthcoming 7 years, for example, for the region of Western Greece. So this is very informative, and it is great to have this automatically produced. Finally, we use the financial scheme assessment. Actually, we are still in the process of fine-tuning the setup. But anyway, we adapted some realistic values regarding these assumptions here. You can see the inflation is really high right now in Greece. We adapted the 10-year loan, and here are the mixture of the amounts coming from different resources. What we want to achieve is to, as year passes, to reduce the own funds and enhance the other sources from European subsidies. As you know, the region of Western Greece is very, very active in participating in European projects and still is looking and seeks for new collaborations to achieve these numbers here, and some national subsidies at this level. But again, these amounts are not enough to achieve what is required for this plan, which is around 1.5 million. And of course, the difference between the resources and what is required may be obtained by a loan. And so by providing these energy and cost related indicators in the financial scheme assessment, this is what we get for the remaining amount covered by a loan. So if one compares all in one loan and different loans, you can see that all in one loan we could have an attenuation of the loan for about 13 years, while the other is not so good. The separate loans is not so good option because the attenuation is obtained by the 18 years, so not so attractive for the region. Conclusions and lessons learned. So, among the tested retrofitting levels, the deep retrofit is emerged as the optimal one based on the assumptions adopted in the decision-making plug-in system. A 7-year gradual renovation plan is emerged, envisaging an average annual investment of around 200 million euros, achieving around 250 megawatt hours energy savings and around 80 to 90 tons CO2 emissions avoidance per year of projects implementation. The deep retrofit presents a viable investment based on even on advanced financial indicators such as the internal rate of return and the net present value. A 10-year loan of around 75%, covering the 75% of the total investment, may be indeed attenuated within 13 years, which is well below the average economic life cycle of the investments. And some lessons learned are that as a result of buildings classification and of the energy analysis required only for ambassador buildings, the impulse tools tackle very effectively the limitation of high amounts of data collection and extensive and time-consuming energy analysis. Because no impulse, all buildings should be simulated. With impulse, only some buildings are simulated and the results are extrapolated to the whole building sample. However, it is true and must be digested by all of us that the reliability and sensitivity of the plan is highly dependent on the correct classification, and indeed only very similar buildings may belong in the same bundle, in the same typology. Otherwise, the plan may be diverged significantly, and of course ensure the aggregative principle of retrofit measures as moving from minor towards deep retrofit. It is important, and you should be very proud of the impulse capitalization, at least in Greece. MES Energy supported and collaborates with the Center for Renewable Energy Sources and Saving in the framework of the horizontal project Efficient Buildings, and through that collaboration, we achieved the result that the Ministry of Environment and Energy has uploaded and recommended the impulse tools as recommended tools for regions and municipalities to conduct their SEACs, the ERB plans. So it is important that the impulse tools may be used for the obligatory ERB plans requested by the new law. So this is for everybody to hear and know as a very good exploitation result in Greece. You may click here for the details in the webpage of the Ministry of Environment and Energy. So thank you very much for your kind attention.